Everyone, I'm Lee. I'm going to start lecture statistical analysis method. There are several methods. Today, the first topic is autocorrelation model. Okay, let's see what autocorrelation model is. Autocorrelation refers to the situation where there is a high correlation among errors in a regression model. When the errors are correlated, it indicates presence of autocorrelation. In ordinary, usual regression analysis, the assumptions you studied about the errors epsilon I are like this. Epsilon I follows independently, identically distributed normal with mean zero, variance sigma square. The errors are independent. However, when the variables are measured over time, we say it is time series. The current value yt is influenced by the past value yt minus 1 and the past error epsilon t minus 1, which can violate assumption of independence among errors, right? This means that when epsilon t is influenced by epsilon t minus 1, the errors exhibit autocorrelation, especially the errors at time t are correlated with the errors at previous times. Thus, when autocorrelation exists, the regression model should be specified as follows. Okay, yt equal to beta 0 plus beta 1 xt plus epsilon t, but epsilon t has some trouble, makes some trouble, like epsilon t equal to k times epsilon t minus 1 plus ut. Ut is called, in this case, white noise. Ut uh, is ut follows IID normal with mean zero variance sigma square. We call it white noise assumption here. So this part is different from ordinary regression model. This model incorporates the influence of epsilon t minus 1 on epsilon t, reflecting that the error at the current time point epsilon t has a certain relationship like this with the error at the immediately preceding time point epsilon t minus 1. Of course, it is possible to consider that epsilon t may be related to errors from multiple past period, t minus 1, t minus 2, t minus 3, and so on. But in this context, we focus only on first order autocorrelation model where the error at time t is directly related to the error at the previous time t minus 1. Okay, simple list autocorrelation model. To easily understand the issue of autocorrelation, let's see what result typical regression analysis method, typical means ordinary regression analysis method, produce when autocorrelation is present. Consider, for example, the following model like this. Let's suppose an autocorrelation model, as you've seen, like this, okay? For example, t equal to t is 1 to 10. Assumption, this one, ut is IID normal with mean 0, variance 9. Suppose 10 randomly generated ut. This is a procedure of a what? A simulation. Randomly generate ut values are 0.05 under this assumption, okay? 0.5 minus 0.7 and so on minus 0.1 and epsilon 0 equal to 3. These 10 values are drawn from a normal distribution with a mean 0, variance 9. From the model, we can obtain 10 error values as shown in the following table, like this, okay? And if beta 0 equal to 2, beta 1 equal to 0.8, then the values of yt obtained from the relationship under this relationship, okay, will be shown as shown in table. These 10 yt values are treated as actual sample values. Here, t is explanatory and yt is some value generated this kind of a relationship. So ut is 0 here, and epsilon t 3.0. Okay, we assume epsilon 0 is 3.0. Then the first generated value 0.5 at, then epsilon 1 is 3.5. 3.5 minus zero point 0.7 gonna be 2.8 and so on. You understand how to generate epsilon t? Okay, then the true relationship is 2 plus zero point 0.8 t. So just here, the value yt is 5. Second value from this relationship with E1, E1 is 6. So we can simulate values of yt like this. Okay, then the usual ordinary regression result for the t values and the yt values gonna be y hat equal to 5.85 minus 0.75 t, which is derived despite the presence of autocorrelation, because it was conducted using standard least square method. In other words, although the true relationship between y and t is this way, right? The result obtained from 10 autocorrelated yt values, which are not independent, misleadingly suggests the relationship as y hat equal to 5.85 minus 0.75 t, which is incorrect, of course incorrect. Then how to get correct solution? So that is what we want some resolution here. Let's see graph. The true mean is here. I mean, true relationship is like this. Y equal to 2 plus 0.5 t. But ordinary least square result gonna be like this. Big trouble, right? Even the sign of coefficient is was plus truly, but you will get minus sign. That kind of a serious problem occurred when autocorrelation present. Okay, let's see how to detect autocorrelation and how to resolve the problem next time. Thank you. Bye.